basically it is called as addressing mode. Okay, so addressing mode is basically a simple topic. Okay, so addressing mode means you know how you know what kind of instructions are there. Okay, so how the operands are dealt with. Okay, so this is basically coined as addressing mode. Okay, in microprocessor and microcontroller. Okay, addressing mode. Okay, so now say for example, it's something like um, something storing variable. Say for example, in MATLAB you can say a is equal to 10. That means that hard code value, the 10 you are storing in a variable, in a variable. Similarly, you can make something like a is equal to pi in MATLAB. So that means the data which is stored in that particular pi variable will be assigned to some other variable. Okay, so what happens. So there will be different ways to access the data for the particular instruction. So this is basically called as addressing mode. So in that regard, so in most of the microcontroller, different addressing modes are there. So first, addressing mode is immediate addressing mode. Okay, immediate addressing mode. Immediate addressing mode means if you are passing any hardcode values to any register in a microcontroller, then it is called immediate addressing mode. Okay, say for example, in case of move a comma ash, say 10h. Okay, ash 10h. What you can see here, the 10 value, the 10, okay, the constant value you are passing to the accumulator. So this instruction is basically immediate addressing mode. Okay, immediate addressing mode. So you can replace this a with any other register, so that will become immediate addressing mode. Okay, so you can replace r1. So these are all what immediate addressing mode. So similarly, so you have something called uh, immediate addressing mode, then register addressing mode. Okay, so register addressing mode. So in case of register addressing mode, so your one of your operand source or destination operands, both are some kind of symbols, register symbols. Okay, so say for example, move a comma b. Okay, so in this particular case, the source is basically some register symbol. Okay, so that is b. Okay, so in the same way, your r1, if you mention like this, move a comma r1. So r1 is also a symbol of some register in a microcontroller. So this kind of instructions are called register addressing mode. Okay, register addressing mode. So the next one is basically direct addressing mode. Okay, so direct addressing mode. Okay, so a direct addressing mode, basically, if your source is from some register, okay, some register address. Okay, so then it is called as direct addressing mode. Direct addressing mode. Say for example, if you have a 8-bit instruction and say for example a comma 20h. Okay, in microcontroller you know this. So what is a comma 20h? So there is a difference between 20h and ash 20h. Like say for example 10h. Okay, so in immediate addressing mode, okay, so if a comma ash 10h, that means the value 10, actual value 10 will move to accumulator, correct? So that is basically immediate addressing mode. In direct addressing mode, if you don't give this this asterisk symbol, then it will be considered as address. Okay, that means whatever data present in 10th address, okay, will be copied to accumulator. You understood? So 10th address is basically internal memory. So internal memory 10th address data will be copied to accumulator. So this kind of instruction is called direct addressing mode. Okay. So direct addressing mode. So you should know this. So the address, the content of this particular address 10 will be moved to accumulator. Okay, so you should know this. So what happens here? Say example, if I write example A is equal to 10h. Okay, so in this particular case, first case, so directly the value will move. In the second case, what happens? Say if R1 is equal to, say here condition will come. If R1 is equal to say 22, okay, then A is equal to 22. You understood? Okay, 22h. Remember this. So if the content of R1 is 22h, then A is equal to 22h. In direct addressing mode, okay, so what you have to understand? So if okay, so in this particular memory, okay, so in this particular memory, okay, so if the content is say 23h, okay, in 10th memory location 23 is present, then A will be 23. You understood? So 23 is the data present in 10th memory address. Okay, so this is direct addressing mode. So similarly, you'll have one more type of addressing mode called indirect. Okay, so indirect addressing mode. Indirect addressing mode means that the data present in the pointed memory will be considered as a address. Okay, so say for example, move, yeah, so move a comma, okay, a comma at dptr. Okay, so in microcontroller at r dptr or r naught, let us consider. So in this particular example, let us see what is happening. So move a comma hash 10 is different. Move a comma r naught is different, or r1 is different. Move a comma at r1 is also different. So what happens in this particular case? Okay, so if r1 is equal to 20, say 25. Okay, the content of r1 is equal to 25. Okay, and okay, one more thing will come. Okay, so the content of the memory whose address is 25 is say 33. Then in this particular example, the A will be loaded with 33. You understood? So this is basically called indirect addressing mode. Indirect addressing mode. Okay. So similarly, this instruction move something like uh, move x a comma at dptr. We are used, right? Okay, dptr. This is basically indirect addressing mode. Okay, indirect addressing mode. So uh, the thing is that the instruction will become independent of some constant value. So that is the objective of this kind of different modes. Okay, so then next one is basically indexed. Okay, indexed addressing mode. Okay, indexed addressing mode. In indexed addressing mode, so along with that indirect data fetch, so some indexes will be given, like say for example move x. Okay, so I'm just writing one example. See, we know move x a comma rtptr. Okay, you understood. So what happens in this particular case? So the content in DPTR will act as an address, and the pointer will go to that particular address. Whatever data present in that particular address will be taken and it will be copied to accumulator. This is what happens. Now assume that you want to increment that particular address step by step. Okay, then what you can do, you can have some index. Okay, index for this particular pointer, like in C you use, right, pointer pointer plus plus. So pointer plus plus basically increments the pointer value. Similarly, you can have some pointer. So that pointer could be accumulated itself, or some register. So if you have this kind of instruction, where if you are passing, some indexes, along with the, the address, destination address, then it is called as index addressing mode. Okay, so index addressing mode. Say for example, I'll use like this. So in this particular case, so if a is equal to say 02, okay, and dptr is equal to 8000, okay, 8000, then okay, and the content of 8002 is equal to say 44, okay, so then okay, a will be loaded with 44. You understood? So that index, that accumulator will act like an index, and that will be added to the address. So this is the characteristic of index addressing mode. And you have one more addressing mode called implied addressing mode. Implied addressing modes. So you have some inbuilt instructions where that source is defined in the instruction itself. Say for example, some exchange, okay, exchange operation. So where what they will do, exchange a and r naught, this kind of instruction they will implement. So in that particular case, you are not giving any explicit parameters. Okay, so the instruction itself will take care of that particular, where it has to fetch the data. Okay, so this kind of instructions are called implied addressing mode. Okay, so swap, exchange. So these are some example for implied addressing mode. So whatever instruction you take, the data movement instruction, data transfer instruction. So all those things will come under some category. Okay, so that is what you have to understand. Okay, so this addressing modes is purely useful for some IO operation. So where the data is taken or something like that. You understood? So this is about addressing mode. Any clarification required on the addressing mode? Just study this, and also study different type of instruction in microcontroller. Okay, so there are data transfer instruction. Okay, so data transfer instruction. So this is basically different types. Okay, types of instruction. So what is first one? So data transfer instruction. So whatever instructions you take in microcontroller. Okay, so if you are just moving data from one point to other point, so that instructions are called as data transfer instructions. Say for example, move instruction. Okay, move x instruction. Okay, move c instruction. So these are all what it does. It just moves data in a microcontroller. Okay, and even if you see exchange. So exchange also basically moves data. So like this, many of the instruction comes under this particular cluster. So that is basically data transfer instruction. Example is move x, move c, and all. So where some movement of data should be there. So even it can be IO operation. Okay, so it can be from the ports, serial port or parallel port. So you may fetch data from any place. So like that, you have some instruction called in and out instruction. Okay, so you can take data from the input output ports itself. Okay, so whether it can be memory mapped IO or IO mapped IO. So all those instructions will come under data transfer instruction. Similarly, you have something called arithmetic instruction. Okay, so arithmetic instruction. So your add. Okay, so add through carry. Okay, subtract. Okay, so multiply. So division. Okay, so increment, decrement. Okay, so all this instruction, you see, So all these instructions will come under arithmetic instruction. Okay, arithmetic instruction. So where some addition, multiplication, division, or indirectly all those things happen. So if any such primitive calculations are happening, then you can bring that instruction under this particular arithmetic instruction cluster. Okay, so that is the second type of instruction. The next type of instruction is logical instruction. Okay, so logical instruction. So logical instruction, yeah, logical operation especially. So okay, and logic, okay, or logic, okay. So not logic, okay, and these things, okay, and at whatever that particular microcontroller provides. So all those things, basically, uh, comes under logical instruction. So logical operation. I mean, some may provide NAND, NOR, and all, and some microcontroller may provide only a few. So you just have to see how many logical instruction this particular microcontroller provides. Okay. So then the next type of instruction is basically uh, control instructions. Okay, control instructions. Okay, so control instructions, control instruction, and I already said some kind of uh, control, and will include the loop here itself. Control and loop instructions. Say, for example, decrement and jump on no zero. Okay, no zero. Okay, so this is basically control instruction. So it basically shifts your control from one point to the other point, or DJNZ, or compare and jump on not equal. Okay, so these are all control instruction. Okay, so your control will move from one point to the other point. Okay, so and also it emulates some kind of looping. Okay, so some kind of looping it will be useful. So if you consider C, any other programming language, what are the looping statement? It can be for loop, while loop, and all those things, right? So similarly here, control instructions are basically shifts control from one point to the other point, and it will be associated in some kind of looping. Okay, so it will be used in kind of some kind of looping. Okay, so these are all different different types of instructions you have in microcontroller. It goes on like this. Okay, so any instructions, whatever they are giving, like say for example 8051 instruction. Okay, so in instructions 8051, so you will find some 8051 instructions, right? 8051 instructions. So if you see this particular instructions, whatever they are providing, if you take all the instructions in the basically you see here, you see this chart. Okay, arithmetic instruction, data transfer instruction. Okay, so and also this control instructions. Okay, and also yeah, boolean instruction, boolean operators. Okay, so you see here boolean instructions, basically the instruction which is changes a bit, any bit is called boolean instruction. So that is also they are given. So in any instruction you take in the microcontroller, so all those things will come to one cluster. Okay, so these are the instructions what you have in micro. This is the complete instruction set. Okay, of microcontroller. Okay, operated with different operands. So all these things will come under any one of the any one of this type. Okay, so just remember. Okay, so the last one is basically boolean instructions. Okay, so boolean instruction. So basically clear C, something like that. So only one bit will be modified in this particular case. So those instructions comes under. So primarily, so there are a lot of bit addressing space in most of the microprocessor and microcontroller. So data one thing, bit addressing is different. Okay, so bit addressing means any one bit in the entire space you can change. Say for example, port 1, okay, bit number 0 you can change using some instruction. So that kind of flexibility is called bit addressing. So microcontroller or microprocessor, whenever you purchase, you can see the in data sheet only they will provide what how much bit addressing capability they will provide. So those spaces you can use boolean instructions to modify. Okay, so even you can modify the program status word also. Okay, so that is also boolean instruction. So clear C is basically changing the clear bit in the program status word. So that is basically boolean instruction. Like that, set bit p1 dot 0. These are all boolean instructions. Okay, so these are all different types of instruction, and these are all different types of addressing mode. Okay, so just if you have any questions, please do ask. No? Otherwise, we'll go for the attendance.